So we want to name the alcohols, and we want to look at the following examples where it says give the structural formulae of each of the following organic compounds. So the first one is pentan 3-ol, butan 2,3-diol, and 2-methyl-propanol. So I'm going to do this as part 1, question 1, right? Pentan 3-ol. Let's start with that one. Okay, so let's just put it out there. Pentan 3-ol, and let's look at this critical example over here. As you can see, pent tells you that there are going to be 5 carbons. The and tells you that there are single bonds between the carbons. The ol tells you that it is an alcohol that we are dealing with, and that's going to have the hydroxyl functional group that is present on carbon number 3. Okay, so as we read it, pent is 5 and has single bonds between the carbons. Ol tells us it is an alcohol that is going to have the hydroxyl functional group present on the 3rd carbon. So sometimes this is written as 3-pentanol, and sometimes it is written as pent-3-ol. I prefer this notation because it is easy to see where exactly the hydroxyl functional group lies. So let us look at this example. So let's start off with pent, and let's make up 5 carbons over there: carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5, right? Single bonds between our carbon atoms, that's what you have over there. And on the 3rd carbon, we need to have and right now it's arbitrary where you start numbering from, so I'm going to make that number 1, number 2, number 3, number 4, and number 5. And then I'm going to put on the 3rd carbon, I'm going to put our hydroxyl functional group, right? O bonded to H. Okay, and there we go. And now you can simply fill in the hydrogens everywhere else. As such, okay, and there we go. So 1, 2, 3, 4, 5, pent, single bonds between the carbons is an, and hydroxyl functional group, the O bonded to the H on the 3rd carbon. There we go. Okay, pentan-3-ol. So what you can do is you can try the exercise first, press pause, and then you can work through the question with me thereafter. Also, I want you to remember that you must write this out, and even if your teacher at school, if you are in a mainstream school, doesn't put the hydrogens in, you need to put it in, because in the examinations, if you miss just one of these hydrogens, we will not give you or award you the marks, right? Okay. Okay, so if you remember correctly, B, the second question wanted, question 1B wanted butan dash 2,3 dash diol, right? And so what exactly is this about? Well, but indicates that there are 4 carbons, so that's going to be 4 carbon. That's going to be single bonds between the carbons. 2,3 indicates where the hydroxyl functional groups are going to be. So there you have the O bonded to H, right? That's your hydroxyl functional group. The di tells you that there are 2 of those, 2 of the same, according to the summary sheet. I want you to go back to it, right? And the 2 of these hydroxyl functional groups will lie in the 2nd as well as the 3rd carbon. So let's do that over there. Let's draw out our carbon atoms. We're going to have 4 carbons. 1, 2, 3, 4. And between the carbons we'll have single bonds. And on the 2nd carbon we're going to have an well, let me put in my numbers just to make things a bit easier. 1, 2, 3, 4. And let me list this over here where we're going to have oxygen bonded to hydrogen, another oxygen bonded to another hydrogen, okay, and then on the, basically we can fill the rest up with hydrogens, and there you go, Bob's your uncle. Okay. Okay, so but, 4 carbons, single bonds between the carbons, we say butan, And on the second and the third carbon, we have two of the same hydroxyl functional groups, second and third. So that's going to be OH and OH. And there we go. Let's look at the third question. Okay. Question C wanted the following: 2-methyl propanol. So, okay. So firstly, we can see that it's propanol. So this here tells you hydroxyl functional group. Prop tells you meth, eth, prop tells you 3 carbons. This over here, the and tells you that it's single bonds between the carbons. And as I mentioned, the OL tells you that it's O bonded to H. Methyl is going to be a branch or a side chain. And it must be on the second carbon. As you can see, the side chain needs to be on the second carbon. If we look carefully at propanol, it doesn't indicate where the hydroxyl functional group is to be located, right? So this could have been propan-1-ol or propan-2-ol. Not really propan-3-ol, because propan-3-ol is the same as propan-1-ol. It just means you need to number from the opposite side. So let's start with the main chain. Let's start with the base over here. Prop is going to be 3 carbons, and we put that in and we say prop is 1 carbon, 2 carbon, 3 carbons. And means single bonds between those carbons. And on the first carbon, let's place the hydroxyl functional group, right? Like that. On the second carbon, let's put a methyl side chain, like that. And let's fill the rest up with hydrogens, right? Okay, and there you go. There you go. We've got it. We've got it. Hydroxyl functional group over there. Ooh, and side chain over there. And now we've addressed 2-methyl propanol. Okay, and more specifically in this case, it's 2-methyl propan-1-ol, because I'm going to make that number 1, number 2, and number 3. Okay, so that was part 1 of the exercise.